Well, we're moving now to solving quadratic equations by graphing. And when we're looking at quadratic equations, the quadratic equation in standard form is ax squared plus bx plus c, as we have already learned. Ax squared plus b, pen's kind of faulty this morning, bx plus c. Now, when we're talking about the solutions, what we're really trying to determine here are what are the x-intercepts. Where is this quadratic equation crossing the x-axis? And we have some other terms that we use for this, and these are all interchangeable. When you hear x-intercepts of a quadratic equation or the roots of a quadratic equation or the zeros, and specifically the real zeros, those are solutions of the quadratic equation. Now, we can determine this by graphing, but we have to get the equation into standard form, ax squared plus bx plus c. Now, this first equation that we're looking at, and we're going to go to the calculator here in just a moment, is x squared plus 2x minus 15 equals 0. It's already in this standard form. But the second equation, I got to do a little bit of work to it before we can graph it. So let's see, I need to move this 12 over across the equal sign. I'm going to do that by adding 12 to both sides. And when I do, I'm going to have x squared minus 8x plus 12 equals 0. Now, first we're going to look at some that have two real roots. Then we're going to take a look a little bit later on one real root, and then we're going to talk about one that has no real roots. But let's move over here to the calculator and let's graph both of these equations. And from the graph, let's determine, and our tables, let's determine where those zeros are, or I might say where the roots are, or specifically it is also the y-intercept. Again, those three terms, x-intercept, roots, and zeros, we're going to use interchangeably. Whenever we refer to that, we're looking for the solutions, the point at which, or the points at which, the quadratic equation in this case, intercept the x-axis. All right, so we're over here on our calculator. We're going to graph this first equation that we had, which was x squared plus 2x minus 15. And so we got x squared plus 2x. And let's see, was that plus 15? No, minus 15. Minus 15. And first, let's just take a look at how this graphs. Okay, so I got a parabola. Obviously, the minimum value is down here off of the screen. I could change my window setting if I wanted to see it, but that's not what I'm looking for. I'm looking for these points right here where the graph is crossing the x-axis. These are the roots. These are the zeros of that quadratic equation. So let's see. When x is, 1, 2, 3, 4, 5. All right, so when x is negative 5, y is 0. This is where we get the term 0 from, the roots, the x-intercepts. We know when we find an x-intercept, we set y equal to 0 and solve. And let's see, we got another root over here when x is equal to 3. Now let's go into our table and let's just confirm this from what we see. And what I'm looking for are the points where for a value of x, y is equal to 0. And I can see right up here at the top, when x is negative 5, y is 0. And when x is 3, y is 0. We have two real solutions. We have two real roots. We have two real zeros. We have two x-intercepts. solutions, roots, zeros, x-intercepts, all terms we would use interchangeably. Now remember on that first equation, which started off as x squared minus 8x equals negative 12, we moved the 12 over in order to graph it and left us with x squared minus 8x plus 12 equals 0. So let's go in and let's graph that. And let's see, we got x squared minus 8x plus 12. And again, we're looking for the solutions. We're looking for the roots, the zeros, the x-intercepts. Okay, and so here I see that we do cross the x-axis twice. We have two real solutions. And one of those looks when x is equal to 2, y is equal to 0. And 3, 4, 5, 6. And when x is equal to 6, we also have y equal to 0. Let's go in and let's just confirm that on the table. And so there we see when x is 2, right down here, y is equal to 0. And we should see the same thing when we get to when x is 6, y is also equal to 0. All right, so there is solving quadratic equations using the calculator.